Hello for everybody. Today I'd like to present the results of improving item searching on trading platform based on reinforcement learning approach. Before starting, let me introduce our team. We are representatives of NTU HPI, Olga Cherednichenko, Maryna Vovk, Oksana Ivashchenko, and Nataliia Stratiienko. We are happy that our team joined our colleague from University of Maribor, Alenka Baggia. Firstly, I'd like to say why so important to improve the item search. Then I highlight the aim of our research. We decided to use reinforcement learning technique in order to solve the task. Then I'll present experiment which was done on 3 trading platforms. And finally, we'll discuss our results. Lately, we have seen significant growth in online shopping. The quantity of online purchases has been raised significantly, and there are a huge number of offers trying to meet demand. Some customers know exactly what kind of product can satisfy their demands. The task here is to find the best offer among a huge amount of e-market sellers. Other customers have a satisfied demand, but they don't know what product with a certain set of attributes can solve a problem. But in both cases, there are some difficulties with commodity searching. Significant growth in online shopping. Overwhelming amount of available items makes confusion. People spend a lot of time in order to get enough information about difference and peculiarities of similar goods. Improve the search process on the web marketplaces. In order to simplify the process of choosing the product for the buyer, the amount of offered goods should be reduced by grouping them on similar features. So, the research questions are: how to combine similar product offers from different sellers on the e-commerce website into a group based on the pre-trained core of text. How response information from e-commerce websites could clarify the item query and increase the accuracy of proposed items. There is a pipeline of e-commerce website interaction proposed in our research. First of all, we need to create the initial query. To do this, we gather data of websites, similar group of items, and build core of text. Based on obtained core of text, we define initial settings for query and define the reward function in order to evaluate feedback from a site. E-commerce website interaction consists of following steps. Firstly, we push the query in repose. We receive the list of items which are relevant to our query from the site point of view. Then, we parse item titles from the response on query. Then, we measure the similarity of attributes and evaluate accuracy of item matching. In addition, we need to take into consideration the amount of items in the response. Actually, we don't know how many items which similar to the ideal item are on the website. The optimal amount of items responded by the website can be found by experimenting with queries. Therefore, to obtain the appropriate item group, we need to change the values of the ideal item attributes in order to meet the optimal amount of the group as well as a high accuracy of item matching. To achieve the goal, we need to interact with website. So, to prepare the experiment, we gathered data about sneakers from eBay website. We create the group of similar items. Here, you can see the examples of items combined by our dataset. As a result of processing our dataset, we created core of text. So, we have the list of words which describe similar items. Let's define K as a set of groups of items. I key as a set of attributes, so every item can be presented as a tuple of its attributes. Let's imagine that we have an ideal item represented by its attributes. From the other side, we have the set of items from the website. We have to evaluate item matching. We apply a Vovk model to evaluate similarity of items. The reward function consists of two parts: relevance of item set and amount of received item. Therefore, to obtain the appropriate item group, we need to change the values of the ideal item attributes in order to meet the optimal amount of the group, as well as high accuracy of item matching. We've done several experiments to estimate usage of keywords for searching similar items on 3 online platforms such as eBay, Amazon, and AliExpress. Table presents the results of attempts to increase reward function. We changed quantity and order of keywords and assessed amount of items and their relevance. We have faced restrictions for the number of words in the search line on AliExpress while performing experiments. The length of the search line is only 50 symbols. It's about 7 words. eBay and Amazon allow applying all keywords, but we obtain unsuccessful results, no matching. However, results are different for these online platforms. On eBay, we obtain 0 exact matching results, but it proposes some results for matching fewer words. Numbers of search results on AliExpress are less than on eBay and Amazon, and they are not relevant. We can see photos of some items which are different color, but there are white options in descriptions. Finally, experiments results obtained on eBay are characterized by two features. The first one is our results are cleaned from different searching noise. We obtain only shoes. However, these items are not always matched our target item. The second one is the bigger numbers of successful experiments in comparison with Amazon and AliExpress. We received relevant items, but the quantity of given items is big. We continued interactions with the website, and after the 10th step, we were satisfied with obtained items. Thus, we suggest using the agent approach, which allows developing a set of attributes, push the search query, receive the response, assess the item matching and its number, and vary the initial attribute values. The suggested model builds a search query by merging words from the core of text, so we can obtain the relevant list of similar products and propose a reference item of the group. The experiments indicated that a group of similar commodities can be generated, but the successful results substantially depend on the e-commerce platform where the core of text was made. Thank you for your attention.